Another identity that you need to learn is compound identities. Now, the concept of compound identities works in such a way that you have sine or you have cos, and in the bracket there is something plus or minus something, and you close the bracket. As far as you can fit in something in here and fit in something in here, it works as a compound identity. Now, one thing you also need to remember about compound identities, if you have sine A plus B, we do not say it is sine A plus sine B. This will be considered wrong. Now that we've talked about what compound identity isn't, let's actually write down the 4 compound identities you need to remember. These are the compound identities that you always need to remember. The compound identities involving sine, we normally have alternating sine cos. As you can see here, we have sine A cos B, and over here we have sine B cos A. Now, another thing to also remember is that whenever you have sine, if there is a positive here, you should have a positive in the identity. The same thing also applies here. If you have a negative here, you should also have a negative over there. So with cos, you would notice that you would have the cos's out of the way first of all, then you have the sines. As you can see, cos A, cos B, then we have sine A, sine B, right? Another very important thing is the signs. Whenever you have a positive, the identity produced will be negative, and whenever you have a negative, the identity produced will be positive. You need to try as much as possible to memorize this. One thing you should also know is that identities doesn't necessarily always have to have A minus B. You could also create your A minus B. What I mean by that, if I have something like sine 5A, this can be written as sine 4A plus A. It could be written as 3A plus 2A, and so on and so forth. But the most important thing I need you to understand about this is that depending on the type of question you get, you will know what you can break it down into. This works a lot with special angles. So take for instance, if I have something like sine 75, and I want to put this in terms of compound identities, it can actually be written as sine 45 plus 30. Then this could be broken down into sine 45 cos 30 plus sine 30 cos 45. Now, if you look at this intently, you can actually see that this represents A, that represents B. We have sine A cos B. You also have sine B cos A. So this is exactly what you do with compound identities. Not every single question will look like the default over here. You might have to create your own compound identities. So we have this question over here. It says prove that sine 15 is equals to root 6 minus root 2 over 4. So like we said before, that we are also allowed to create our own compound identities. We understand that 15 could be rewritten as 45 minus 30. Could also be rewritten as 60 minus 45. Now, if you're wondering why exactly am I choosing special angles, what you need to understand is that if I choose any other value that creates 15, it will be difficult for us to answer this question without using a calculator. But with special angles, like we talked about in previous lessons, we don't need a calculator to simplify questions like this. So I'm going to rewrite this as sine 45 minus 30. From compound identities, we understand that this here would be that's A, that's B, So therefore, that's A, that's B, and that's B, and that's A. So the line you see over here is just me using special angles. For 45, for 30, I'm breaking them down into this. Then by simplifying the first part here, I multiply the root 2 times root 3 gives you root 6, 2 times 2 gives you 4. That's why we have this over here. And this here is 1 times root 2 gives you root 2, and 2 times 2 actually gives you 4. So this is wrong, sorry about that. So that is 4. There you go. Then with this, we can just use the concept of LCD. So this will just be 4 root 6 minus root 2, and that's your answer. So this is another example of how you could use compound identities.